For one of our homework problems, I ask you to prove that the trapezoid method, and if I can highlight this right, is the average of the left and right. In other words, it's 1/2 times the sum of the left end plus the right end. Okay, so you're going to start realizing what the trapezoid method really is again. Over a subinterval, you have the average of the bases, the average of these two bases times the height. The height is delta x, and the base here is f of x sub 0, and this is f of x sub 1. So your formula is average of the bases times the height, and you add those all up over all the subintervals. So that's what trap in is. So my suggestion to do the proof is to do this. Write out what the actual trapezoid sum is. Here the delta x over 2 was factored out, so you're going to get the first subinterval. These are the two bases added up. Second subinterval, so this is the first, this is the second subinterval, this is third subinterval, and so forth until you get to the end. Okay, then you're going to clean this up because there's some things that can be simplified in there, and organize it and try to get it into this form here, which is the average of the left and the right. Okay, so how are you going to do that? Well, the left starts with x sub 0, that's a, when your interval is a to b, and ends off at x sub n minus 1, and all it is rectangle sums. So it's the f of x heights times the delta x. So that's this sum here ending at x sub n minus 1. And then, of course, times your delta x factored out. The right sum starts at f of x1, in other words, the height at the right-hand boundary of the first subinterval, and counts from 1 to n, and adds these up, times with delta x. That's the only difference between the left and the right, is that you don't have this first value here, and you don't have this first value here in these last value. Okay, so somehow you're going to notice that there's a relationship between all this stuff here and this stuff here, and you probably already can see it, but in case you're having trouble with that in the abstract, here's a trick of the trade. If you can't do a proof in the abstract, then always try a particular case first to see the patterns. So you're either going to try a smaller abstract case or a completely hardwired example with an actual function like x squared or something and some numbers in there, and make it small and short. So I chose to show a smaller abstract case here. Here's your function. There's only two subintervals here, x0, x1, x2. So you know your a is, that's your a and that's your b. So there's only two subintervals. So we have this smaller case, and we go over here and we see, so your trap 2 is just going to be fitting these trapezoids here and this second one here. So it's going to be average of the bases times the height, average of the bases times the height on the second one, so those are two covered right here. Factor out delta x over 2 and get this, and it's looking pretty easy now because you can see some relationships there, so you just keep going. Okay, then you notice that the left 2 is just this, and the right 2 is just this. So it's a smaller abstract case that you can handle. You can write the whole thing out with all that, without all that dot 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 stuff in there. So you're trying to show this. So why don't you add up the left 2 and the right 2 that you have there and see what happens, and then you just generalize the process. Now this proof is a type that can be done with a chain of equal signs. In other words, you're going to go all the way from trap to the average of the left and the right with a chain of equals. But sometimes it's hard to go all in one direction, so it's okay during the development of the proof to work one side halfway and the other side halfway and see if they can meet up in the middle, like a couple of trains coming from the East Coast and one coming from the West Coast. Then rewrite the proof all in one direction from one side to the other, and you'll look like a genius.